Good morning, majors. Today we're going to go over Unit 10, which is beginning solids, and this is day 1. So I just wrote Unit 10, day 1 on top of my paper. We're going to go over just the surface area of solids today, and these are all the solids we're going to look at. The sphere is probably the easiest because there's only one variable. We're going to say it's 4 pi times whatever the radius is squared. And that's how you find the surface area, or the area of the outside of a sphere. Um, we're going to talk about prisms next. A prism is a 3D figure whose faces are polygons. Most likely they're going to be rectangular or triangular polygons. We'll see some others also. It says the bases are the parallel and congruent polygons. So this would be a base. This has 1, 2, 3, 4, 5 sides, so this is a pentagon, and this bottom one would be a pentagon. That's also. These are the only two that are going to be parallel. The lateral faces, we're going to go over lateral edges. Make sure you guys read these and understand these. An altitude is a segment that is perpendicular. This is a symbol for perpendicular. If you don't know that, write in the word perpendicular to the bases, with an endpoint in each of the base planes. This is the formula for the lateral area. This is on your formula sheet. Your lateral area is your height times the perimeter. So this is the height. Sorry, there's a lag. And the height of the prism is going to be the distance between the bases. So this is going to be the height because this is the top base, the bottom base. So this would be your height. And then P stands for perimeter. And this is the perimeter of the base. So the outside going along the edge, the outside of the base. Total surface area of the prism is the surface area of the prism is the sum, which means we're going to add up, of all the faces, including the bases. Alright, so this is the formula for the total surface area of a rectangular prism. Length times width multiplied by 2, length times height multiplied by 2, and then width times height multiplied by 2. So basically we multiply everything together once, and then we have a 2 in front of them all. This is the formula for all other prisms. It's the height times the perimeter, and then, which we have up here, and then plus 2 times capital B, which is area of the base, not base. So LA stands for lateral area. We're using this formula. This HP, it comes from the lateral area. And then our H is for the height of the prism, which we already went over. And then P is for the perimeter, which we already went over. The perimeter of the base. Capital B is the area of the base, not the base itself. It's the area of the base. So underline this word area. It's very, very important. All right, find the total surface area of each solid. What I'm going to make is, first I'm going to write down the formula for this rectangular. See, the bottom is a rectangle, the top is a rectangle, the sides are rectangles. So I know this is a rectangular prism. I know my surface area is, I'm going to write it down from the back page, 2 times length times width plus 2 times length times height. I'm going to put it in the same order. Plus 2 times width times height. Okay? And it doesn't really matter what you choose to be your length and your width and your height. Just write something out. I'm going to say my length is 15. And I'm going to say my width is, I don't know, 8. We could pick anything you want. And then that makes my height going to be 10. Okay? And I'm just going to plug it into the formula. My surface area equals 2 times 15 times 8 plus, and then 2 times the length times the height, so 15 times 10, and then plus 2 times the width times the height, so 8 times 10. Everything should have been multiplied together once, and it looks like it is. So plug that into your calculator and tell me what the answer is. For number 2, this is a triangle on the bottom. This is the base, even though it's actually facing me. This is the base right here, and this is the base over here. And those are the only two that are going to be parallel. So that's why I know those are the bases. They are congruent also, but they are definitely parallel. So my area of the base is different on this because my capital B is the area of my triangle. We know area of a triangle is 1/2. The bottom of the triangle is the base of the triangle, which is 3 times the height. So in this case, my area of my base is 1/2. Like I said, my base is 3, and then my height is 4. 3 times 4 is 12. 1/2 of 12 is 6. So my base is 6. My capital B is 6, and my area of my base. So my surface area equals the lateral area plus 2 times the base, which we said my lateral area is, we plugged it in. We have my height times the perimeter plus 2 times capital B, the formula. So I'm going to plug it in. My surface area equals, the height is going to be the distance between the two bases, which we said that's going to be the line that connects them. So that's 6. My perimeter is going to be, we're going to add up the numbers on the outside. And in order to do that, I need to use the Pythagorean theorem because I don't really know what this third side is, unless you guys remember what kind of triangle this is. I don't remember what the hypotenuse is. So we're going to have to use a squared plus b squared is c squared. 3 squared plus 4 squared equals the hypotenuse squared. You guys are going to get 5. When we add this up, this is 5, 9, 12. So the perimeter is 12. Plus 2, the area of your base we found out is 6. So I'm going to put this one as 6. This 6 is where we got this one. So all you have to do is plug this into your calculator and you'll get the surface area of your triangular prism. Alright, now let's look at a cylinder. A cylinder looks like this, like a can. They love to use like can of Coke or a can. And it says, a cylinder is a solid whose bases are congruent, circles. So if the bases are circles, then that's a cylinder that lies in parallel planes. Parallel, this is a symbol for parallel, and I'll put planes. Just remember that they're parallel to one another. Axis, the segment whose endpoints are the center of the bases. A right cylinder, this is usually the one we use. A cylinder whose axis and height are congruent. That's the same thing. So the center is going to be the same as the height. Okay, the total surface area of a cylinder is your lateral area plus 2 times area of your base again. So the lateral area on this is going to be kind of like the circumference of a circle going around the circle. So it's 2 pi radius times your height plus 2, and then your base is pi r squared, right? That's a circle. So this is going to be your surface area. And what's really nice is this is on your formula sheet for you. So you really don't have to memorize this. We just have to know how to use it, how to plug it in, what these variables stand for. So my surface area is, I'm going to rewrite it, 2 pi RH plus 2 pi r squared. We know what r is, that's our radius. H means the height. So the height, in this case, is 10. That connects my two bases. My height is 10. My 2 pi is not going to change. This is not a variable. My r will change. 2 pi. Now I need to find out what r is. They're not always going to give us r. Sometimes they'll give us the diameter. But in this case, they do. It's just 6. And then this is going to be r squared. Okay, so I just plugged them in. My r equals 6. And then I found out my height equals 10. Just plug them into the formula. Plug it into your calculator and see what you get. Alright, I'll let you guys do this one. Let's go over a pyramid. A pyramid is a solid with a polygon base and a vertex. So what's really special about this one is the base can be any type of polygon. It could be a square. Usually we're going to see a pyramid has a square base or a rectangular base, but it has to be a polygon on the bottom. Polygon base and a vertex, which means that my polygon, my solid, is going to have a top that comes together at a point. This comes together at a point. This is a vertex. The lateral faces, all faces except for the base. The lateral faces are triangles. These are all isosceles triangles, actually. So I can write isosceles or just put triangles and then put isosceles. Specifically, they're going to be isosceles. The vertex is the point right up here that they intersect, that all lateral faces intersect. The slant height is super, super, super important. People, if you forget anything, people usually forget this on the SWL. This is probably the most important thing because it's new. This is the height of the lateral face of a lateral. Sorry. So this is going to be the slant height. Right here. Remember this. And the symbol for this is an L. It says a regular pyramid. Remember, this word regular means all my angles and sides are equal. A pyramid whose base is a regular polygon. Maybe a square. In this case, maybe a hexagon. I don't know how many sides it has. Polygon. The altitude intersects the center of the base. So it just goes down straight to the center of the base. Okay, lateral area of a pyramid is the lateral area is 1/2 the slant height times the perimeter of the base. Remember, L, italicized L, is slant height. This is something that's kind of new. And P is the perimeter. Okay. So the total surface area of the pyramid, and they give you both on the SL worksheet, is the 1/2 L, the slant height, times the perimeter, which is the lateral surface area plus the area of the base. Remember, capital B is not base, that is the area of the base. Okay. It says find the surface area of each figure. So let's do this one. Let's do an example. My surface area, I'm just going to write over here, my surface area equals 1/2 my slant height, which sometimes they'll ask us to find, times the perimeter plus the area of my base. So we know that if my base is a square, that to find the area of a square, it's just going to be like multiply the two sides. But if this side's 6, then this side is 6. So we're going to multiply them. 6 times 6 is 36. So I'm going to write it out here. Capital B equals 6 times 6. And then 1/2. Now my L is going to be my slant height, and that is given to me this time. So I'm gonna write it in there as 5. And then the P means the perimeter, and that is 6. And now we're adding plus 6, plus 6, plus 6, which is 24, I think. Okay, and I'm going to plug that in, times P. Okay, plug that into your calculator. Remember, there's a plus right here. Kind of got cut off. And tell me what you get. Write it down. All right, guys. One more. Okay, so now our last one is a cone. A cone is a solid with a circular base and a vertex in a different plane, of course, from the base. That's okay. Just remember that you guys know what a cone looks like. The altitude, it says a segment that has one endpoint at the vertex is perpendicular to the base and has other endpoints on the base. Don't worry about it. Slant height, again, that's very important. A segment from the vertex of a right cone to a point on the edge of the base. Okay, a right cone. It says the axis is also the altitude. We're going to be working with right cones. Oblique cone is a cone which is not a right cone. Any other cone is an oblique cone. Oblique cone. So we're gonna work with right cones because then we can use like the Pythagorean theorem and stuff like that. We have a formula. It says the total surface area is equal to pi times the radius. And really, they multiply it out or they distribute it on your SL worksheet, and it's times the slant height plus the radius. But if you multiply it out, it'll look a little bit different. I'm going to distribute this term right here to both. So you might want to do it this way, or just multiply it out, and this will be pi RL plus pi R squared. Same thing. Same exact formula. And remember, L is your slant height. And you guys should know already that radius, or R is your radius. Okay? Alright, let's try one of them. Let's try number 2. You guys could do number 1 for me. Number 2, it says, well, let's plug it in. I'm going to first write down my surface area formula. I'm going to write this formula down. Pi RL plus pi R squared. And I know that my radius is 3 and my L is 19. They actually give that to you. Oops. So I'm just going to plug it in. Pi 3 times 19 plus pi times 3 squared. Okay, just plug that into your calculator and see what you get. In order to get the slant height in this one, which is this right here, we've got to use the Pythagorean theorem. Do you guys see this triangle right here? So if this right here is 8, and we don't know the radius, But if the whole thing is 16, then the radius is going to be half of that, which is 8. And then you're going to use, this is going to be your right angle right here. And you're going to use the Pythagorean theorem to find the blue or the slant height. And remember, this is your hypotenuse, so this is your answer. L squared equals, and then we have 8 squared plus 8 squared. Tell me what L is, plug it in, and then find the total surface area of number 1. Alrighty guys, have a great day, and we'll see you in class tomorrow.